This is the video for section 2.3, the first video, about the product rule. So before you go any further, stop this video and do preview activity 2.3 if you have not already done so. This is really important and it will help you to not make a very common mistake once you start taking derivatives of products. Okay, so now that you're back and you've done preview activity 2.3, you know the very important fact that if I have two functions and I multiply them together and take the derivative, that is not the same as the product of the derivatives. Differentiating a product is not that simple. But fortunately for us, it's not that complicated either, and we will see why in class. The product rule is if I have two differentiable functions, f and g, then f times g prime is f prime times g plus f times g prime. So that's the product rule. That's how we differentiate a product. So let's see some examples of how we would apply the product rule. Let's differentiate the function m of z equals 2 to the z times cosine of z. Now the first step is you have to recognize that this is a product of two functions, and it is. The first function is 2 to the z, and I'll just denote that f, and the second function is cosine z, and I'll just denote that g. So the product rule says, okay, if I'm going to take the derivative, that's going to be f prime times g plus f times g prime. So f prime is 2 to the z natural log of 2, times cosine of z, which was g, and then f is 2 to the z times the derivative of g, which is negative sine z. And the rules that I used, well, to take the derivative of f, I used the exponential rule, and to take the derivative of g, I used the cosine rule, the derivative of cosine, and of course, before that, I forgot to write this. The first rule I used was the product rule to get the derivative of f times g into f prime g plus f g prime. Okay, now let's differentiate the function 3x cubed times x squared minus 1. So just a note, we could do this as a product rule. If you wanted to do some algebra first, you could multiply this out, distribute the 3x cubed, and then just use power rules and sum and difference rules. But let's do this as a product rule problem. So I will notice that this is the product of two functions. Now I'm going to be a little sloppy, and I'm going to call 3x cubed, I'm going to call that pink f, even though my whole function is called f. So just, this is perhaps a little bit bad notation, but I'll at least keep it as a pink f instead of a blue f. Blue f is the big whole function. So that's 3x cubed, and then little pink g is x squared minus 1. So if I take the derivative of this, well, I take the derivative of f, which is 9x squared, and I do that using the power rule. And then I take g and just leave it alone, so x squared minus 1. And then I take f, which is 3x cubed, times g prime. How do I get g prime? Well, I use a power rule on that x squared. I use a sum and difference rule to separate that x squared and that minus 1. And then the derivative of minus 1 is 0 by the constant rule. And of course, the overarching rule I used here was the product rule. So you may notice, and you should think about why this generalized product rule is true. What if I had a product of more than two functions, like 3 or 4 or n functions? Well, what you could do is you could sort of go piece by piece. You could use the product rule, you could split it up as two pieces, use the product rule on that, and then use an additional product rule on whatever is sort of left over. So you can think about how you might prove, given the product rule, you might prove that the following statement holds. So let's say I have, for example, 3 differentiable functions. Then the generalized product rule says that f times g times h prime is f prime times g times h plus f times g prime times h plus f times g times h prime. So let's take an example. let's say I have P of Q is Q cubed times cosine of Q times sine of Q. So you should recognize this first as the product of three functions. So we'll use the generalized product rule here to compute P prime. So we'll take the derivative of F, so that's 3Q squared, we'll leave G and H alone, plus Q cubed times the derivative of G, which is negative sine Q times H, plus Q cubed times cosine of Q times H prime, which is cosine of Q, because that's the derivative of sine. And here we have calculated the derivative of P of Q. So we use the power rule to take that derivative of F. We used the derivative of the cosine to take the derivative of the cosine. We used the derivative of the sine to take the derivative of the sine. And the overarching rule we used was the product rule.